Operation Second Line at the Baytown Refinery. Operation Second Line at the Baytown.
Howdy. I'm James Swanson. I was a Chemie class of 2021. I'm currently crude coordinator for our refinery in Baytown, and I've worked in manufacturing, technical, and supply chain. So happy to be here.
Howdy. I'm Justin Hill, class of 2012, and I'm currently a lead electrical engineer in our global projects group. basically working on all innovations and ideas with ExxonMobil.
Howdy. I'm a Zoo. Worked for Exxon 8 years. I graduated 2010, PhD in chemical engineering. Right now, I'm the supply chain real-time optimization supervisor.
Excellent. Those are our judges, ladies and gentlemen. So, without any further ado, let's get started. Team EXXON, if you would come up, and let's begin Aggies Invent. And just wait until you see your slide.
Oh, okay, that's what it should have been. Oh, yeah, come on, buddy.
Hello? My husband didn't come home last night. He was supposed to take the kids this morning before my hospital shift. He always calls. He always does. I think something's wrong.
Now, with EchoLink, with real-time location tracking and vitals, a rescue team can be deployed before disaster strikes.
Rescue team, this is operator at Offsite Command Center. We have a man down at heart rate of 145 and a respiratory rate of 32 at coordinate 32.1701 minus 102.4287.
Is he okay? Thank you for finding him in time.
Welcome to EchoLink, where every signal sent, every second tracked, can save every single life. We want you to meet Jacob and Natalie Dean. It was just every other day where Jacob had went to the facility, and when he had opened the door, he was exposed to a toxic gas, H2S, and almost immediately passed away. After several hours, no one had located his body or known he was in distress, and after several unanswered calls, his wife decided to go to that facility, where when she opened the door, she was also exposed to that toxic gas and sadly passed away. At EchoLink, our goal is so, despite unreliable signal, we are able to locate and track any person. Every single loss is a lost life.
Exactly. So this is where our need statement arises. We need a way to find workers reliably in emergency situations.
So to come up with a solution, we had some factors that we considered as the key decision factors. The first one is reliability. So how reliable will be the system? Will it work in an environment which has a lot of steel around it? Will it work in a refinery? Will it work on a rig or not? The second thing is coverage. Will it cover the whole globe? Will it work onshore? Will it work offshore? And if does it require GPS or does it not require? The third is the security. What security measure does it have? Can it only share the location to the ExxonMobil or the particular company, or will it be a localized network where any public domain can see the network? The third is the speed. How fast can we track the person? How fast can we report an incident and that incident without having an error in it? The fourth is the safety, not just the safety of the system, but the person. So if that person is using the product, will he be safe? Can he use it with his PPEs? And if he's using with the PPE, will it interfere with his work or not? So to come up with the solution, we found out two different technologies. One is the LiDAR tracking, the other is the GPS tracking. The LiDAR technology is not reliable, as any person who would not be in line of sight of the LiDAR technology would not be visible to the software itself. So it lacks in the visibility of the person. The second is GPS. The GPS is highly reliable until and unless you have a satellite above your head. If you are in middle of nowhere and the satellite connection is lost, you might be lost at that moment. And if you have an incident at that point, we might not even know what time or what place was it happening. To satisfy all of this criteria, we developed a model which is EXXON.
Introducing the EXXON band, engineered with reliability. Every signal, every second, every life. So, how does it work? We're using ultra-wideband technology. You may know this in AirPods or AirTags. And from there, we use anchors. These anchors can be placed in every company truck or in missions where there's heavy personnel, like working over a well. You can place these around the pad to ensure connectability. Next, the next step in our process is going from the anchor to our software. We will normally use Starlink, which ExxonMobil already has operations using this, or when satellite or GPS is not available in these remote conditions, we can use EPRS systems. Here are some of the features. For example, a man goes down, he's unresponsive, not moving for 45 seconds straight. An alert will happen on the device, and he has 10 seconds to press interactive button on the side to ensure he's safe and does not need help. There's also an emergency button behind a slide mechanism, so it ensures it does not get pressed accidentally. This button is for high stress situations when there's something happening and you need emergency services there on time. Next, our band tracks your vitals, so heart rate and breathing rate. For OSHA standards, this is breakable technology, so it does not get trapped in machinery.
So once the link band keeps the worker connected, this interface allows the rescue team to view the situation from above. This is our landing page, our central command point. As you can see from the monitors around the screen, we have the active number of person active, meaning how many people have the band on hand. Next one, you have the active area. Where could the personnel be? The third one and the final one is the number of active incidents. This is the most critical one as the number increments, we will see an alert pop up on the screen. And the rescue team can actually click on this alert, which leads to our map view. I want to bring your attention to the right panel. This right panel first provides the worker status, meaning all the critical information that one might need to contact family, such as emergency, and like obviously the name. Next, we have the vital monitor, like heart rates, respiratory rate, oxygen level, temperature. I want to highlight the fact that these vitals are color-coded by how urgent the situation is, so that our rescue team can send the appropriate need to the victim. Finally, we have the incident trace, which lists all the events that has happened in chronological order and also rank them based on criticality, meaning the most critical incident will be on top so that our rescue team can prioritize the things that need to be prioritized.
So our Geo database integrates seamlessly into Starlink satellites. And I want to highlight that you can filter by incident so that you're not confused by how much data there is. And it only tracks the workers when they're in an emergency situation.
We've introduced to you the EXXON data dashboard and EXXON band. So now we're going to present how that would look like working in the system. So first, it is a continuous feedback between the band and a UWB anchor on the truck. This feedback would be so that we can have instantaneous information received by the command center. This command center will receive information via the Starlink satellite in situations where we do have good access to service and data. In the cases that it is not, we will resort to the APRS system in order to send that information. This system depicted is for operations for single users, but in the scenarios where we have multiple groups of people, Our system is able to adapt to handling several bands at once, with the UWB having a capacity of connecting to 8 bands.
Here at EchoLink, our goal is to save every single worker's life and ensure that every signal is sent, so we can save people just like Jacob and Natalie Dean. My name is Faith Larimore, and I'm an industrial and systems engineering student.
I'm Thrushil and I'm a sub-C student.
My name is Nate. I'm manufacturing mechanical engineering technology student.
My name is Sarada. I'm a computer science major.
My name is Mohammed. I'm a geographic information science technology major.
I'm Jara and I'm an industrial systems engineering major.
And together, we are EchoLink, ensuring that when everything else fails, EchoLink prevails.
Judges, over to you. Who has the first question?
You said each module can connect up to 8 individual, person monitors. Was there a technological limitation that limits the number that can be tied to one module? Or
So there is a higher number, but we're preparing for the worst case scenario. But in an ideal situation like that, you would hope to have more than one truck there, which will handle the bigger capacity.
So on the system, is it like if you had 3 or 4 trucks in the area, whoever's closest to each truck, it will just automatically pair to each truck? It's not like linked one to one.
Yes, sir. It will be the closest to get the best connectivity.
you said for like a manufacturing facility, like one where maybe there might not be trucks nearby, you can have the modules spaced like throughout.
Yes, like it could be 4 corners, and this is optimal for like open air settings, like the rig. But for a refinery, maybe oil, offshore, it would have to be a lot more, so a heavier investment, maybe as a future application. But it's still, the technology still works for all applications.
So when I look at it, it would do well. You need more receivers along, like for like an FPSO will have a bunch of metal.
Yes, sir.
I mean, basically around that hinders communications already for us.
Right.
And so
it would just take a larger investment for more of those anchor points.
In our development process, we had decided to optimize on a system that's priority onshore, so that because 70 to 80% of all operations are on land.
now, does it mark when they take it off?
Yes, sir. So it'll show 0 pulse. I mean, if you go like that, your pulse is not going to go from a normal range to 0. So that could be sent to a manager. Hey, why did you take it off? It's part of
someone to go check on.
Yeah, it could be like your safety protocol, just like hard hat, glasses, vest, same thing.
And alongside that, if you don't have it on, an alert will go off because you don't want your respiratory system to go from normal to 0.
Who's actually monitoring the data and looking at the database?
So we'll have 2 displays that we're going to have the software on, and we'd have an off-site location as well as an on-site location at those muster sites, so that individuals who are close to the event would be able to reach those people with a rescue team, and the off-site can enable a rescue team in order to reach those people.
So is the idea that your company helps monitor, or is it you give, for example, ExxonMobil the package and train them on how to use it? Like how does
ExxonMobil, the rescue team of the ExxonMobil is well capable of handling any situation. So this software will just help you to understand the incident that is happening. So if your person somewhere in the field is lost or unconscious, how do your system reacts? So to reduce that reaction time and the response time of all of that system, we have this system in place, which will just alert the rescue team of ExxonMobil saying, your person is down here, please make sure you reach them as soon as possible.
So it's kind of adaptable, because I'm taking a refinery will have a rescue team in operations nearby clustering points. A well site, I mean, I'm going to want to choose an emergency group that's closest, and usually that's not ExxonMobil's emergency group. It's going to be send someone life-flighting out.
Further development, we can also implement that the nearest point, the person who is the nearest person who is wearing a wristband can be located as soon as possible to the nearest injured person. So it's not even the rescue team who has to be there, but any nearby lease operator can go out there and check on him.
Your system will integrate with the EXxonMobil existing system, or you will add an additional system. This is a new system in your database, new, or you will integrate with existing.
It will only require the Starlink connection system that has to be integrated with the EXxonMobil. Other all system can be like a separate, like a software package and just the wristband with the module.
Is information stored on the cloud? Is it stored in a server room, in a data center? Is it where are we, like, all this information? Because you're going to get a ton of information.
So the real life tracking of the person will not be done by any of the people on EXxonMobil. It will be done by the software.
Okay.
So software has already captured, it's been in a real time loop in capturing the information. So if the person is okay, that information does not be required to be stored by the cloud. So it can be pushed away. If in case of incident, it can be stored in cloud.
And that is 5 minutes, and that is EchoLink. Thank you. Our second team needs to please come up and set up, and that is Petro Crawl. Thank you again, EchoLink. Petro Crawl, please come to the stage. And after each pitch, of course, the judges need a moment to calculate, to check on their scores. So we want to give them time to do that, just a little bit of time to calculate. And then David's collecting them, and he will tabulate at the end of our competition today. So down is forward. Thank you. Yeah, let me just say that to everybody. Down is forward. So the down button moves it forward. Yeah, that makes sense. Yeah. So just hang tight and please take off. Timer will start. Good. Deep breath. Here you go. All right, let's give it up for Team Petro.
We are Petro Crawl.
Robots can wash your car, vacuum your house, and explore Mars, but we still send people into fuel tanks with flashlights. It's 2025, and our workers deserve better. OSHA estimates that 2.1 million workers enter confined spaces every year. At ExxonMobil, that means entering a tight space with toxic gases and no visibility. Drones have made inspections safer, but not exactly smarter. PetroCrawl knew there had to be a better way, and we found it. Our hardware solution is the PetroCrawler, a robot never before seen by the petrochemical industry. It has the capability to maneuver vertically and horizontally and gather data all around without the limitations of drones. As it stands, each inspection means days of downtime and hours spent on acquiring permits and making manual reports. These costs add up fast. Safety shouldn't come at the expense of efficiency. That's why our team constructed a dashboard, a software platform that turns data into decisions. It streamlines the process from collection to analysis to reporting. The resulting inspections have shutdown time cut in half and an elimination of confined space-related injuries. Our software would save thousands of man-hours and millions of dollars per year. Technology should do more than replace people. It should protect them. Progress isn't about machines doing the work. It's about humans and machines working together. If robots can explore Mars, our software can make confined space inspections work right here on Earth.
When we walk into our workspaces, our study spaces, we enter there to do work, to get our job done. And we enter with the assurance that we are going to leave at the end of the day. Now, as I'm sure you know, at ExxonMobil, part of running an energy plant is routine inspection of the different components. This can be distillation towers, reactors, different pressure vessels. And a way that that is done now, the primary method is manual inspection. Now, a human being will enter into these confined spaces and take measurements, record that, and convey it to the rest of the team. However, this can come with risks associated with it, even when all the safety protocol is followed. 6 confined space fatalities have occurred in the petrochemical industry in the past 10 years. The fact that that number is not 0 is reason enough for manual inspection to be reconsidered. Another thing associated with manual inspection is the time and the cost. Downtime is a huge element, when the part is shut off for the safety of a human being in there, the part is not functioning and ExxonMobil is not making money. So for a solution to this, we considered multiple aspects, human health at the forefront, and we wanted to minimize that downtime element with a machine. We wouldn't have to consider purging the vessel. And we also needed to maintain the ability to navigate confined spaces. And we needed a solution that included all of these elements. And we found that solution for you. It is Petrocrawler.
So the question we had when we first thought of this idea was how is what we wanted the Petrocrawler to achieve. So first of all, for human safety, the workers will be able to work remotely and they won't have to enter confined spaces such as distillation towers or pressure vessels. And for training with machinery, it will be reduced by 25% compared to normal methods because you will require less permits and less training overall. And for the inspection duration, it will be reduced by around 55%. So with manual inspection, it takes around 6 to 12 hours to complete with multiple shifts. But with using a Petrocrawler, we can reduce that to 3 hours in just one shift. And for the cost reduction, since there will be no manual inspection, scaffolding isn't necessary, and the downtime costs will be reduced significantly.
I can assure you that Petrocrawler has specialized features for confined space inspection in ExxonMobil facilities. Now, first, let's talk about the top of the robot. The camera is a 360-degree swivel. It'll see in any direction, and it'll see up in 90 degrees, allowing for a full dome of visibility. And the modular top will allow you to add any sensor and allow for any sort of data collection, which will then seamlessly integrate into the software side of things. It'll automatically be set for data management. Now let's talk about mobility. Now let's talk about the mobility aspect and navigation. So this four-legged design allows it to move kind of similar to a spider. At the bottom of the legs, there will be electrostatic adhesive pads. When you add a voltage, remove a voltage, it'll stick and not stick at will. Basically, it creates like an electron field, electrostatic field. I can explain more in detail in Q&A. And for safety, one of the main things that we considered when building this thing was safety. The battery is a 24 volt lithium iron battery. It's it's meant best for safety. It's the lithium ion battery which is the most safe in these situations because when you're entering a confined space that has flammable gas, an explosion can cause the entire facility to burn down. It's very bad. So the battery needs to be enclosed in a safe enclosure area. We'll have ceramic composites outside the aluminum body, basically allowing for operation in all different types of high temperatures.
Imagine an inspection robot that would go beyond the limits of wheels. Unlike traditional robots, our Petrocrawler design features 2 different joints on each leg, which allows for flexible movement, and that maximizes the stability for the base of the robot. Our robot offers an all-terrain inspection capability and adapts to extreme temperatures, ensures safe and comprehensive inspection of pressure vessels, storage tanks, and reactors. Petrocrawlers works quietly, reduces downtime, and works with advanced sensors that increases the inspection time, that decreases the inspection time and minimizes the maintenance time, thereby increasing the productivity and efficiency than the conventional wheeled robots. Petrocrawlers offers unmatched versatility by means of with sensors and foot modules, be able to switch within seconds, which means that it could be the right tool for any inspection task and any wall materials and any conditions.
We talked to the EXXON people and we built a dashboard that seamlessly integrates data collection, analysis, as well as representation. And how are we going to do this? We use machine learning pattern that gets the good tank as well as bad tank data. It's trained on these images, and using a supervised learning algorithm and label data, it's able to identify anomalies when our crawler goes into these spaces. So after identifying, it's able to categorize these anomalies into cracks, dents, wears, or buildups, along with sensor data that supports this visual data. And if you just want to see the sensor data, for example, here we have the distance and sound sensor. For example, if there's a leak, the crawler is able to identify exactly where it is in the tank, as well as identify any decibel differences, so we can identify leaks. It's just one example I showed here. And we also have access to previous inspections. So once we do an inspection and everything gets fixed, the crawler can go in again and do another inspection, and you can compare the before and after aspects and see exactly what's different or if it's been fixed. And you can also download the full report with all the data, images, and all the things. So all the data centralized can be shared across countries to different employees, and it's all managed with ease.
Right, so what do we have now? We are presenting you with two solutions. We are presenting you with hardware and software. And you might be wondering, how are these things integrating with each other? It is seamless integration. As soon as that petrol crawler is getting that data, it is generating a report in the center of the computer. It is generating a report for the employee. We're chopping down the time being wasted on generating reports. We spoke to employees who expressed unhappiness with spending time just monotonously putting data into Excel sheets. You don't have to do this here, right? So I want to talk about the impact. The impact cannot be overstated. We are reducing costs, but we are also increasing global data sharing. That means your employees in Kuala Lumpur, the employees that are going to be in Guyana, are going to be able to speak easily to employees in Houston. And the Houston employees can say, hey, I think this leak is from XYZ or whatever issue may be. We are streamlining the process and phasing out human inspection, but we know that you, the wonderful employees of ExxonMobil, cannot be replaced by a single AI model. So that is why we are keeping human involvement there, because it is pertinent. As we have shown you how we climb up the walls of success, we would love to open the floor for questions.
Woo! Good timing! Who's got the first question, judges?
I'm gonna ask a question. On the design of it, so you're going into a classified area, most likely with some type of explosive gas and static. Have y'all considered static contact? So when you're doing voltage level feeds for magnetics it can create a static field, which can ignite some of our product gases.
We haven't fully thought about that yet, but what we're planning on is the bottom part, the electroadhesive part. That part will also be modular. There are other ways to do the same thing. For example, vacuum suction cups. So what we could do is, on certain terrains or in certain confined spaces, we can have the electroadhesive legs, I guess. And then on other parts, we can have the vacuum suction. And basically, it'll be completely modular. You are correct, I guess. This wouldn't work in all terrains, but we would have other options.
And some of those terrains, we can essentially replicate what geckos are doing, just on a bigger level.
Question. Can you tell me why you feel your solution is better compared with the drone solution? I didn't see that your solution is better.
Yeah, so
drone can do it as well.
Yeah, you're right. Usually, what they have in the industry now is drone solutions. One thing that we were thinking of is like the aerodynamics of it in confined spaces specifically. So when a drone is generating lift, propeller spin, the air vortices, it pushes air down, the air then goes around, right? In a confined space, that can mean the air goes back into the propellers, affects the aerodynamics of the drone. So in order to, just not think about all that stuff and not have to worry about that stuff, we bought in a robot instead. And also cost. These are generally just cheaper. We estimate about 2 to 3 times cheaper. Also, when you're operating a drone, the drone operator has to be licensed, right? You can just have a random guy come in, operate the drone. That guy has to have at least 4 to 6 weeks of training to operate that drone. 4 to 6 weeks, that's a lot of, in downtime, that's a lot of money, that you could be making those 4 to 6 weeks.
To add on to that,
when we inquired about operating drones inside the reactors and the pressure vessels, they said that they have to remove or blind the pipelines and other stuff. So it will increase the downtime as well. So with the petrol crawler, it doesn't need to be removed, so you can crawl through anything. So that's one thing. And one more thing is about the battery life. So drones would have last longer, but our petrol crawl has better battery capability.
I didn't mention it, but we estimated about an 8-hour battery life. While a small drone, because you wouldn't be able to use a larger drone in these confined spaces due to other factors. A small drone, we searched it up about 20 to 30 minutes battery life. With this thing, it would be about 8 hours in ideal conditions, but that's still more than enough. Even if it's not ideal conditions, it's still more than enough time for inspection.
So on a column, this thing would be climbing on the sides of the walls and around, because you're going to have tray levels in the columns that they're going to have to avoid. So this would climb around it, similar to how people.
Yeah, that depends on the wall condition. So if it doesn't get wet with the electrostatics, we change it to the suction cup, or it's electrostatic adhesives.
One thing in my experience that has really hindered phasing out human inspection is a lot of these reactor and vessel internals require tactile feedback to verify like the bolts are tight. If there's rope packing, you want to make sure that's tight between components in your reactor. How does your solution eliminate or I guess satisfy that kind of tactile component of inspection?
So we're not completely eliminating human inspection. This is just the robot is a way to see what type of inspection needs to be done, right? So it goes through and it identify all the type of anomalies that do exist, so that people can go down there and fix it, which obviously reduces the time that the person has to be in there in general.
And to add on, may I? To add on to that, we did also primarily consider the visual aspect, seeing buildup, seeing cracks. We were told that we were informed that is a huge chunk of the inspections being performed. So even if it doesn't cover every single thing, that would take out a large percentage. We don't think that it will be completely realistic to completely phase out human inspection, because people will need to go in there to repair it as well. But to reduce the fraction of people being exposed to these confined space situations.
7 seconds. Can you ask a quick?
Have y'all considered temperature?
Yes.
Yeah, that's really true.
There's a lot of material.
There is some positive.
Fair enough. That's 5 minutes. Yeah. 5 minutes. Let's give it up. So, as we are deliberating and the judges are calculating their scores, Safety Net, you're next. So, Safety Net, if you could please take the stage. Professor Cafano will be loading your presentation, and we will get started in just a moment. How you doing? Strong start. Yeah. This is good. This table in the right place for you. This work. Think about it. Think about it. You move this table forward. Are you sure? Who's got the clicker? Who carries the clicker first? Who holds it first? Yeah. Wait till you see as long as it goes. Okay. You good? Are you locked and loaded? Good? Are you guys good? Does it start with a black screen or does it?
A man is dead, another seriously injured.
Sometimes forget just how dangerous and tragically deadly the job can be.
A man has died.
One man was killed and 2 oil field workers injured in an accident outside Seguin.
Dead from a sudden oil field accident Thursday morning.
An industrial accident involving a forklift. This morning, one person was hurt and was taken to the hospital.
In an industry built on precision, it only takes one moment of uncertainty to cause a tragedy.
Heavy machinery collisions remain one of the leading causes of injury and death on oil and gas sites. One worker is killed by heavy machinery every 12 hours. That's 2 workers per day, 14 workers per week, and 728 workers per year. But what if there was a way to predict and prevent these collisions in real time? Traditional safety methods have reached their limit. Warning lights, backup alarms, and training programs can only go so far, and yet collisions on work sites continue to claim lives. That's where emerging technology steps in. With the rise of the Internet of Things, we now have the power to connect machines, workers, and data in ways never before possible. Introducing SafetyNet, where needless workplace casualties become a thing of the past. Through a mesh network of static nodes and mobile IoT devices, we've made smart, real-time detection a reality. Our system identifies potential collisions before they happen and intervenes instantly, overriding heavy machinery to prevent impact and protect lives. SafetyNet, where innovation meets protection.
Howdy. This is SafetyNet. Now we've just explained why this is an issue, but we're going to demonstrate why this is a problem. Now you may have one question. How are we going to keep people safe without needlessly stopping operations? So imagine this. I am an ExxonMobil worker on site, and I'm aware that machinery is always going around me. I need to work on these machines. The great thing is, this device does not give me needless alarms and no distractions regularly. But in the workplace, collisions are bound to happen, and chaos will ensue. This device will give me 2 different types of warnings. 1, a vibration will vibrate, and 2, an audio that's loud. And this is the interlocking mechanism. The interlocking mechanism is determined after these 2 signals that the human receives are ignored. So to summarize, these are 2 different signals that are given to the human, and if they are ignored, that will happen. It will interlock, it will freeze operations, and will ensure that the human is safe. Now, once everything is said and done, I can simply take off this module after my shift, put it back in charge, so that it's ready for the next day.
To come up to this solution, we have evaluated 3 different technologies: RFID, cameras, and SafetyNet. That is our technology. We evaluated this on 5 different criteria, which is generally a barrier for integrating new technology for the safety. First is cost, then eliminating the human involvement, downtime, and integrating it with the existing technology, and usability in the all weather conditions. While RFID provides a reliable identification, it has a lower range as well as it does not reduce the human involvement. For the cameras, it gives us a detailed visual feedback, but it does not work very well in all weather conditions. Whereas our solution, SafetyNet, combines the best of both data as well as the sensors and accurately determines the human and the equipment on site.
So you might be wondering, how does all this work? It seems ambitious. Well, SafetyNet is effectively a mesh or a network combining data flow, fixed nodes, and mobile transmitter devices. The mobile transmitter device is equipped on personnel, and all heavy machinery communicate with nodes, and the nodes communicate to an external processing unit that forms triangulation to create pinpoint location data. Using this location data, safety radii can be established and created. And once again, warning systems can be created when people get too close. Even further than that, once collisions are imminent, then interlocking can take place. So allow this simulation to kind of show what's going on. We have our static nodes, we have our personnel outside the danger zone, with location being pinpointed by triangulation from 3 nearby nodes, and a mobile heavy machinery represented by the orange block, and a red radii showing that when danger is there, interlocking takes place. And once the radii is clear, the truck can once again move.
So you might be wondering, what technology are we going to be using? We're going to be using LoRaWAN, which stands for Long Range Wide Area Network. These signals are long range, low power, and bidirectional communication, which means that the end devices and the gateways send each other information. This means that we have extended range and scalability. Many different sensors can also be connected to the network. So our smart decisions, how are we coming up with these outcomes? We have 3 data points: distance, velocity, and hazard radius. These data points are sent to the main server where one of 3 outcomes will occur: continue operation, hazard identification, or automatic interlock.
Our technology can be integrated on every step of the EXXON mobile operations, be it on the pad construction using dozers, trucks, and excavators, to drilling rigs using cranes, forklifts, and trucks. Throughout the operations, including frac and well servicing, as well as on the downstream and refinery sites. This is made possible because with our technology, you can adjust the radii of the risk zone that you can see in the red here as per the equipment.
If safety is such a major concern, why have previous attempts failed? Previous attempts have failed due to limited visibility and blind spots. Operators are unable to see around their vehicles, and poor communication makes these matters worse. A big factor is human nature. We as humans aren't perfect, and if we're going into work every day doing the same routine and nothing's going wrong, we tend to let our guards down. What makes us different is we eliminate effects of our human nature. We're able to integrate our technology with existing technologies without disrupting workplace operations.
SafetyNet has redesigned the meaning of safety in the workforce. Our technology works for humans, not against them. We have helped with human error, limited visibility, and blind spots. Our technology helps by going into the spot and helping humans avoid these errors. So now, would ExxonMobil like to be known for the company that prevented every accident, avoided every injury, and made sure that every single one of their workers went back home because of their safety and all the precautions taken? Welcome to SafetyNet, where the future of innovation meets protection now.
What did you have in mind for a mechanism that would be installed on the moving heavy machinery to stop the movement suddenly?
And so we were thinking a hydraulic override on the brake system. Yeah.
So on the system, is it the end place of the data making the decision to stop a vehicle, or is the vehicle itself sensing where things are making that decision?
Right. So for the data flow, like once again, we have our mobile transmitters that go to the nodes. But the nodes have to go to an external processing area so that it can form triangulation from 3 different nodes, right, in order to establish location. In that same center, it's going to be able to look at all of the location data going around, and it can make that decision, and then it can send that data straight to the mobile receiver on the heavy machinery.
Did you do any research about the complexity or the size of your solution?
Say that again.
The complexity or size. For example, you apply it to lubricant plant or lubricant warehouse or refinery.
Are you asking like how many nodes we would need in order to make this feasible?
How many nodes you will have? How many flows you will have? Do you consider that?
So it depends completely on whether or not you're in an environment where signal strength is high, whether it can be sent. So if you're like in an outdoor area versus like if you're inside a warehouse. But these nodes aren't expensive. You can place them everywhere, and all you need is to have 3 in proximity in order to accurately transmit your location.
Also, the nodes are relays. So if there's like a wall and you have like a node over there where there's no wall, and there's a node here and then the node behind the wall, the node can send information to the other node, and then that node can send the information that's behind the wall. So the information will get around everywhere.
So you include different kind of ASQs. Also, for example, something will fell down. Also, will include that.
Say again?
So something you're on the top, maybe fell down. You also will include.
Yeah. So it uses antenna and like frequency, like radio frequency. So the higher up, the antenna can signal, like can reach everything. So you want some high up that will like reach all of the IoT devices.
For construction sites, so when you start looking at places that are greenfield, there's nothing out there, and they start doing work. Is there like mobile units you put out there?
Right. So a great aspect of this project is its mobility. Like we said before, referring to a previous slide, it's applicable every step of the way, from pad construction down to the refinery and downstream management. So it's able to be unplugged, moved easily. The mobile transmitters are just simply placed onto the devices that the personnel. It's really quite mobile.
But does the system collecting the data have to be at that site, or like if I don't have power?
Not necessarily. No. It can be a server room.
Okay. So it goes to satellite, or just how does it get to the server room?
Yeah, satellite.
Okay.
Is there an upper end for how many pieces of equipment can connect to the nodes?
So there's technically a packet limit around 20 bytes, but when you factor in how many node IDs you can fit into 20 bytes, it's pretty much limitless.
And the nodes, do the nodes have to be stationary? I'm thinking of like
the nodes are typically static.
I'm thinking of like a construction field where there's not a structure that you can adhere these things to potentially because you put them on the ground, or do they need to be high up above?
They don't need to be high up above. That's more of what he was referring to in a warehouse scenario where you have walls and stuff like that. Yeah.
1 minute left for questions. Any other questions? We good? All right. Let's give it up for Safety Net. Thermalink, if you could come and get set up at the front. Thermalink is next. Mr. Fred's putting your presentation up there. I think I saw. Here we go. Let's just check this. You start with blank screen. Start with the video. Let's put your hands together for, tell me your name, keep name again. Thermalink. Thermalink.
One, are you good to keep working? Yes, sir. I can keep going. I'm good to work. Juan, are you okay? Juan? Hello? Hello, Juan, are you okay?
This is exactly what we're trying to mitigate. Every year, over 3,300 people face the tragic consequences of heat stress. Why is this? Human perception. Humans tend to be the worst judges of themselves, and in an environment as unforgiving as the oil and gas industry, one bad judgment call is all it takes. Our solution? Introducing Thermalink. We may not be able to prevent extreme weather in the workplace, but with Thermalink, we can prevent its harm to ourselves. By monitoring vital signs such as core temperature, heart rate, and further external factors like age or weather, workers can be notified when they should take a break in order to prevent heat exhaustion before it arises. Will you protect your wings under the harshest sun, or risk an ending like Icarus? When the heat begins to rise, let Thermalink guide you to safety.
We are Thermalink, and we don't guess, we predict. Howdy, I'm Pranav.
I'm Juan Pablo.
I'm Pranali.
I'm Galindo. I'm Thomas. And I'm Nico. Right. So after performing our customer discovery, we noticed that current heat stress mitigation measures have been proven to be ineffective, unsafe, or too costly to be implemented. And according to data compiled in 2021 and 2022, manufacturing and construction industries contribute to around 43% of all workplace heat-related injuries. That is significant. And due to these heat-related injuries, these industries are losing $186 million annually. But how?
Heat stress and heat stroke, fortunately or unfortunately, come with their indicators. For example, here we have the WGBT, or wet bulb globe temperature, which essentially measures atmospheric and environmental conditions and then categorizes the severity of the environment. However, this neglects one thing, very important thing, which are personal indicators, such as biomarkers. These, for heat stress and heat stroke, can include things such as an increased core body temperature and an increase in heart rate. There are currently solutions in place to deal with these things, such as cooling trailers, swamp coolers, and the buddy system.
The issue with these current solutions are that they are reactive but not predictive in determining heat stress. There's also a huge prevalent stigma in seeming weak, because workers often feel that if they clock in and say that they are undergoing heat stress, that they are incompetent to their other peers. Second, and thirdly, there's also a human error aspect in determining heat stress. For example, if I were to supervise you, I could not accurately discern whether you're having a high core temperature or a high heart rate, because there's a human factor involved in this. And lastly, all these solutions contribute to a disrupted workflow because workers are taking more breaks, which decreases overall productivity. And so this compiles into our 5 design requirements. We propose that the weight added from sensors should not exceed 200 grams. Biometric reading should be accurate. There should be a huge operating temperature range. And the useful lifetime of these devices should exceed the worker's shift range. The first solution we came up with was chest straps. Chest straps offer accurate biometric readings and are sweat resistant. However, they're uncomfortable, and many workers will not be able to integrate this into their daily work routine. The second option is safety glasses. This will work using a clip-on sensor at the end of the glasses at the edge, and it would be a biometric reading sensor. But the issue with this is that it is not as accurate as other measures. Also, safety glasses are lightweight, but this also means that they are more fragile.
And so our third solution was the hard hat visor. This solution takes advantage of current PPE requirements in the oil and gas, manufacturing, and construction easily, so it would be easily integratable into current systems. And so when we take into account all of our design requirements, it's clear to see that the hard hat visor was the best solution. Unlike the chest strap, it is familiar and comfortable for workers to use in a long shift. And unlike sunglasses, it is able to better take biometric data to give better degrees of accuracy. And so this is how our visor would fit into current hard hats. So along the front, we have 2 sensors that take 2 key biometric measurements. Along the forehead, we have a thermopile that takes measurements of the core body temperature, and on the side we have a module that takes into account heart rate. All of our systems are powered by a battery here at the back, and all of our data is compiled using our onboard processor to then be sent to a centralized dashboard using existing infrastructure. The way that would work, you just put it on like this.
Our hats will communicate with the server, where a server will have an AI to screen and detect for biometric abnormalities. Upon these detections, they will both contact the site supervisor by call through a automated phone call, as well as a buzz to notify the employee that action must be taken in order to assure their safety. Upon compiling multiple data points of these, we can generate a dashboard where we're able to monitor multiple employees and their risk factors. For instance, Jonathan Carson
with the dashboard, we're able to know that both his heart rate and core temperature are above the healthy range. In addition, he has also worked 10 minutes above his recommended work volume. And these 3 different factors will generate 3 independent phone calls to his supervisor, as well as 3 buzzes on him to notify both the supervisor and the employee that action must be taken to assure his safety. Lastly, our product offers guardrails that will allow for $186 million in terms of reduction in liability, as well as material costs, allowing us to deliver $186 million worth of value to the construction and manufacturing industry.
Ultimately, with our product ThermoLink, there are numerous number of short-term and long-term impacts for both ExxonMobil and for the workers. For ExxonMobil, there is an increased compliance with regulations, and there's also an increased productivity among workers since there will be a better work balance. And it also minimizes the amount of legal and medical risks associated with these kind of heat stress conditions. Furthermore, for workers, these life-saving alerts can be the difference between life and death. And so with the reduction of accidents, there's also an enhanced comfort and trust within the system and with the company as a whole. For our long-term impacts, with the digital health infrastructure, ExxonMobil will be able to optimize the work rate balance for their workers, and then they also can lead the world in global safety and ultimately show the world its priority of safety, which is its #1 concern. And this can also lead to sustained savings in insurance. For workers, these heat stress mitigation factors can lead to improved health outcomes, and they can also work for longer periods and work more productively during those periods of time. And so to sum up, the system hasn't worked for quite a while. It demands dozens of lives every single year and also costs hundreds of millions of dollars. However, it doesn't have to be this way. We can end this guessing game. With ThermoLink, we are able to deliver accurate, precise, individualized, and objective data to ensure that every worker is cared for without the subjectivity of having to make sure each worker has to discern for themselves whether they need to take a break. And so we're ready to take the next step with ExxonMobil to advance global safety worldwide. And ultimately, with ThermoLink, this is all possible because we don't guess, we predict. Thank you.
Thank you, ThermoLink. Thank you very much. And the next step with ExxonMobil is questions. So, who's got the first one?
All right. How do you predict guarantee the prediction accuracy? We mentioned using AI or other AI help.
So I can go first. How we want to do is we have the sensors throughout the visor, and so we have blood heart rate, and then we also have core temperature, which are the 2 biggest factors in determining heat stress and heat exhaustion. So what we want to do is we're able to measure those along with other factors such as what the temperature is around you and like the wind and other environmental factors. And so those kind of factors all together, along with what we already know about the workers, should be able to predict when they should take breaks and yeah.
So it's a prediction, I say, which the accuracy, how to guarantee the accuracy based on the AI. Mention the 2 factors. You already know the 2 factors. How you guarantee the accuracy?
That would be, we haven't thought about the model or algorithm yet, but that's definitely something that we're considering.
And something that we would have to consider after a long period of training of the model. And so that would look like going through extreme outlier cases and just developing an algorithm that combines both the weather and biometric assessments and kind of creating an algorithm that combines both to create an index score that can then determine if the worker will undergo heat stress.
So is the sensor built into the hard hat, or is it something that's placed in with each hard hat?
Yeah. So it's the
detachable. So a lot of our hats, what we found out, they have slips on the side, so it's easily clippable. They kind of replace the current
suspension
that you have on there, and just integrate into that. So again, just going back to the integratable, it's something that's already familiar to a lot of workers.
and the weight of it is
so we went for less than 200 grams. So.
just going. I mean, I wore a hard hat for many years. The comfort level is going to be the big key for workers because if it's not comfortable, they're not. So I just wanted to see if y'all take that into account.
I noticed y'all mentioned that it has a processor in the device itself. Do you think it might be possible to just use the piece as the sensors and transmit the data and then do the processing away from the device itself to save weight? Or do you think that would provide any benefit?
Yes, that was our initial thing, is that it transmits data to like a localized node to compile and generate a dashboard for the local supervisor, and then also transmit it to HQ for data purposes as well.
So on the heat part of it, like, so it's a lithium iron phosphate battery that is powering the system. Have we taken account for how you're going to cool it with being on the head and no airflow? The processor would get hot.
Yeah, so our so it's just kind of a prototype. So on the typical suspension you have the adjustable notch. That's where we would integrate it. So allow for the airflow and not be inside the head because it would get hot inside the house.
1 more minute left. Other questions? Anything that comes to mind, judges? Are we good? Think so? Let's give another round of applause. Thank you very much. You know what I really appreciate is the focus in this room. It's so quiet you can hear a pin drop. It's funny what happens when $5,000 is on the line, you know? And I really, really appreciate the focus and the support of other teams as we listen. And that's really going to be important because the judges are making their decisions, but you've got some decisions to make as well. What's the video that you've liked the best so far? Which prototype has stood out for you? There are going to be other things on that survey that you will take. And some teams here will take away bragging rights for knowing that you have stood out as selected by your peers, as well as selection from the judges. So, without further ado, our 5th team is, and I apologize if I missay it, Panoptes. Is that right? All right, Panoptes, take the stage, please. You guys good? You all set? You're up and rolling?
Explosion and fire at an oil and gas site. 1 man is dead, 3 more injured.
After a worker's death in September.
Yesterday's explosion is just the latest accident at a Colorado oil and gas site.
4 workers entered a confined space to investigate a potential gas leak. Their names, Crystal Wise, Wade Baker, Gilbert, and Robert Donato. They never made it back out. Not because the job was impossible, but because they were the first line of detection. The air inside was filled with methyl mercaptan, a fast-acting, invisible, lethal gas. No warning, no remote inspection, no data collected before human entry. Only uncertainty, followed by tragedy within minutes. These were fathers, co-workers, friends, people who went to work with the expectation of coming home. Right now, we have the capability to send drones into confined spaces, and that has already reduced significant risk. But current drone systems stop at just capturing data. They don't interpret, they don't analyze. This forces companies to do manual reviews, costing time and money. That is the gap we fill. Panoptes doesn't just enter tanks, it understands them. Using AI-driven scoping, real-time hazard recognition, and automated structural analytics, we turn raw inspection data into actionable intelligence. Today, we are not just improving drones, we are redefining industrial inspection by making data faster, smarter, and life-saving.
Howdy, we are Panoptes. Together, we are making safer solutions more efficient.
The drones are currently being used in confined spaces, but they have their limitations and inefficiencies. During customer survey, talking to the ExxonMobil employees, we discovered assembling and disassembling large-scale drones for confined spaces to be a big hassle, take a lot of time, and cause a lot of experience. Also, when the drones are inside the vessel, all it does is capture footage. It doesn't analyze, it doesn't interpret. All it does is collect hours of raw data footage for the inspectors to go and analyze. That sounds like a pretty long and inefficient process, doesn't it? And all while this is happening, units are completely down, costing companies millions of dollars in revenue. This only adds to the stress of employees. They have to work on hard deadlines and take shortcuts to ensure the safety of the plant, sometimes putting their own lives at risk.
So you've heard of the problems that we have currently in the industry. What can we do about this? How can we make EXXON more efficient overall? Let's talk about safety. This is a big problem in this industry. How can we improve worker safety and overall limit their risk of exposure inside of these vessels? Next, efficiency. How can we keep time and accuracy in mind when we think of a solution for this problem? Reliability. How can we ensure that our solution is dependable, consistent, and trustworthy for ExxonMobil?
Materials. Are the materials that we're using for our solutions something that's compatible with the petroleum and gas industry in ExxonMobil? Finally, feasibility. Is our solution something that's realistic and doable, or is it just an idea? So here we have a decision matrix of some of the solutions we've considered, including some that we came up with, as well as the current solutions. So currently, we know that, as you may know, ExxonMobil uses drone and the camera attachment, and this drone will be able to take pictures of the interior of the pressure vessel and capture the footage and record the data for professionals to review. But while the drone is very reliable and it's very secure and safe, we understand that sometimes efficiency can be a problem. As stated earlier, in one of the anecdotes that we learned from ExxonMobil workers, they had to disassemble the drone and take it inside the entryway and reassemble it because it was too large. Additionally, because professionals had to review the footage because there's just so much, it can take a long time. Then we have an idea that we came up with the wall climbing robot. While we thought that this robot was very safe and efficient, it solved this efficiency issue, we discovered that it wasn't as reliable as the drone initially, because there's just so many more variables when you have a solution that's grounded instead of a stable flying drone, such as, for example, pressure vessel may not always have a smooth surface for the drone to climb on, for the robot to climb on, or the robot may be more in contact with contamination and corrosion rather than a drone being able to navigate around.
So what we ultimately decided was that feasibility was going to be our most important constraint. All of the options were safe, but it doesn't matter how safe they are if we aren't able to actually implement this. You can hypothetically save thousands of lives, but we need something that works now. So what we decided on was a drone with detachable arms so that it's quick to disassemble and assemble. It has autonomous navigation, which cuts down on operator error, and then it uses local AI for decision making. This cuts down on the review time because the drone is able to see a spot that looks slightly abnormal, review what the next steps might possibly be based on the information it's been trained on, and then give that information in real time to the technicians. So what we have here is a prototype of a drone that could be disassembled as far as the arms. As you can see, you can quickly attach each arm to the drone, like so, using a process that does not require a lot of power tools, thus improving safety, as we aren't having technicians out in the field who may not know much about the engineering of the drone. We're not expecting them to have to figure out on the fly, how do we disassemble this? How do we reassemble it? There's also no heavy equipment required to assemble it. You just screw the arms on and plug in a wire so that the propeller is still able to get power. It's also more efficient because this is intended for less technical people to be able to disassemble and assemble. It's also very feasible. We're not trying to reinvent the wheel. We know that drones work. We just need to find the inefficiencies within them and improve them.
Our drones have to operate in tight, complex environments. No traditional navigation system can help us do this. We use the LiDAR technology. It dynamically maps this vessel. This allows us to detect the obstacles, as well as our algorithm on board comes up with a flight path for the optimal flight path which the drone can utilize. Think of it like a Waymo, the self-driving car. We use the same technology, but in an industrial space. This is very reliable as it allows us to go through various complex geometries as well as low visibility scenarios. Also, as you can see right here in a simulation video, our drone right here successfully avoids the obstacles as well as detects all the defects. As the drone navigates through the vessel, it inspects, it detects all the faults which can be corrosion, using the onboard cameras and also the thermal, the infrared sensors. This, once it is detected, it is tagged to the LiDAR map. This is again compressed. This data is compressed and streamed to the operator, which allows him to which gives him an idea of the vessel. Also, it cuts down on the post-flight analysis. This reduces the downtime overall and in turn improves the efficiency.
Financial impact is an extremely critical factor to focus on during downtime for inspections. For example, let's look at the Beaumont, Texas downstream refinery that ExxonMobil has. So, as you know, a very critical unit in the downstream refinery is the fluid catalytic cracking unit, commonly known as the FCCU. The Beaumont fluid catalytic cracking unit has a production capacity of 120,000 barrels per day. By using conservative costs, this is approximately daily revenue of $10 million, which translates to $300 million or even more in a month. The upper bound on how long these inspections normally take for a vessel is 12 hours. And when a technician goes out and does the inspection, then he has to send the data. Then they have to send the data to the office for further review and instructions. And this communication window can take up to 4 hours, according to the mentors. This is roughly 33% of the time of the total inspection. By using our technology, you're able to reduce this communication window to a few minutes. And unit-wide, this saves a lot of time. And as you can see from our data, our solution is very cost-effective and time-effective. And from our video, you can see a lot of lives have been impacted by confined spaces in the oil and gas industry. Today, we at Panoptis are going to change this. Thank you.
Thank you, Panoptis. Thank you. Excellent. Very nice. Judges, who has the first question for Panoptis?
So you say it makes its own report basically comes out right after the inspection. What's taking in all those data points? Is it going to a server? Because the data points itself are going to be massive from an inspection. Is that going to the cloud and back, or is that how's the data flow between taking the picture to what's given the report solution?
That's a very good question. The path planning algorithm is specifically everything is done on board. So the LiDAR data is computed on board. We plan to use the NVIDIA Jetson Orin, and it's about 80 grams the weight, and our model will be using the lightweight CNN model, and we plan to optimize it through quantization, cloning, so that everything can be done on board, and we don't have to send it to an external cloud service. Does that answer your question? Yes.
Is there a minimum size requirement for the confined space, or what are the size limitations?
Yeah, so if you want to flip to, you have a slide for that. OSHA, we're looking at replacing humans, so we looked at the smallest hole that OSHA will permit a human to be expected to go through, and the number we found for that was 24 inches. And from talking to the mentors, some of the drones can be bigger than 3 feet at their widest when you're trying to fit it through. So what we were thinking was having the maximum folded outer diameter would be just under 24 inches, and then it's able to expand out to about the size that it would be needed for those tests. Does that answer it?
Yeah, I was more thinking, once you're inside the vessel to give the drone, right, so that it's not running into the wall, is there a size limitation of the vessel itself from a diameter standpoint?
So for the size of the vessel, there's not really a restriction because what we're trying to create with our solution is more of a universal solution. So no matter what the vessel is, our solution will work for that vessel.
Questions? Anything else, judges? Anything else come to mind? Let's give it up. And now, as the judges deliberate, we've come to the place in our program, because we have 9 teams today, where we're going to take a break. But the important thing, and I need you to lean in on this for me, is for you to come back in 10 minutes. Right now, synchronize your watches. I've got 3:25. Let's be back in here and ready to go at 3:35. Can you do that for me? We'll see you in 10. Thank you. Are you intrigued?
We'll come to the end. We'll come to that's when we went into your account. You want to boards, and then it might be some winners just to build a little tension. Yeah, exactly. It's quick. It's not like so it's quick. Figured it'd be like it's not instantly gonna take it's real fast. Anything right going back and forth. It's hard. That's so cute. Like a nice expression. Oh, you want good things. He was actually missing like all because there was too much. He's like, I take it back. He's like, I take it back. He just said, oh, the start really smart. Not how it's supposed to be. Wow. I didn't do any minor right? One semester. Oh, good. Yeah, but I can look all the. I would do mine too. I liked it too. Like it too? Yeah. Here? No, by like oh, yeah, I was like, wait a second. You're saying something different. I can hold it up. Oh, that's our camera? Oh, you see one? Yeah, I went down though. Not like that. Nice. Yeah, people around. Something. It's not a job, also. I guess what, like I'll stand like right there. We're just talking to like right here. I guess they're like trying to catch up. I'm here to make the content.
Why after
I guess they like look at it.
Analyze standards and use that controlling and slide. I don't know what you're at, and I don't know what they want. And what's wrong, babe? I'm just still I have lots, but I like working. I mean, maybe we could get on that way. Probably not editing everything. Like the
Welcome back, everybody. Are you ready for the second half of Aggies Invent? I'm excited for this part of the competition. Let's keep the momentum going. I'm very encouraged. I'm very proud of what you brought to the stage so far, and I look forward to seeing what the other teams are going to be doing. Stand up. Make your mentor proud. The next team is Logic. Please come up and take the stage. And just to let you know, judges, when we wrap up today, you'll be able to go and deliberate. There's a small room back here where David will meet you, and you'll have an opportunity to discuss, which will be important, especially if it's close, which I anticipate it might be. Fair enough? Okay. Let me turn around and work with that logic. I'll be right back. Ha ha ha. You're going to need that. Good.
Inspection complete. Moving to the next valve. Control, I don't feel right.
Confined space emergency. We've got a man down. Get medics inside.
You just can't prevent these incidents. It took them too long to reach Jerry.
Hey, boss. Jerry might not make it. Is there really no way to keep people out of the towers and tanks?
Every year, thousands of workers step into danger just to keep our lights on. Climb, crawl, descend, and enter the unknown so that energy keeps flowing. Among them, lives lost, futures changed, families shattered, not because people didn't care, not because safety rules were ignored, but because sometimes accidents happen. when humans are placed where no human should ever have to be. Confined spaces, rusted tanks, scalding steam, toxic air, routine jobs, inspections, maintenance, checks that could be done differently, that could be done safely. Intralogic. The only way to prevent an accident is to not be there at all.
Howdy. Howdy. My name is Aaron Lee, and we are Intralogic. A complete solution to your biggest concern, human safety. Pressure vessels, storage tanks, and distillation columns are critical components of any oil and gas operation. Due to ExxonMobil's high safety and quality standards, these assets demand detailed interior inspections. However, current solutions are undesirable by sending a human into these closed, confined, safety, and CSE environments, which can be defined by these three undeniable facts: high risk, high cost, and highly inefficient. Let me put the risk into perspective. On average, it takes 360 human hours of CSE per unit per year. That is 360 hours of a human in a tight, dark space, 360 hours of potentially toxic vapors such as hydrogen sulfide, and 360 hours in an environment where no human should venture. Between 2011 and 2018, the Bureau of Labor Statistics reported 128 occupational fatalities across the industry in confined space environments. We at Intralogic refuse to believe that this is the only solution. We are here to change the standard. But what makes this problem so complicated, and what would make a solution ideal?
Thank you, Aaron. So to decide on our solution for y'all, we came up with the design criteria, acronym CARV. To start with C for cost, we have a projected hope to get 50% minimum price reduction through the CSE inspection area. And we want to improve accuracy and robustness. We want precision down to 1 millimeter, these small pits that are hard to detect through other methods. We also want 90% confidence in those measurements. And for robustness, we want our drones, our solution to be able to function after unpredictable events. For versatility, we want our solution to be able to be modified so that it can go inside of many different types of vessels that it may be required for. And lastly, we want efficiency. We hope to achieve between 50 and 80 downtime reduction. So for our time, we want to slash that greatly to improve your cost greatly as well. And this here graph is our decision matrix visualized through a radar graph. And our conclusions from this, Reina can explain further.
Thank you. So, what will be the answer for the question earlier? How can we improve safety, decrease cost, and improve efficiency? The answer is our Intralogic Eagle package. This is a two-pillar design, which will eliminate the need for human beings to enter those hazardous and confined spaces. The first pillar is automation. It's an AI-driven drone. And the second pillar is accessibility, which will drive. It's not only about hardware, but also software to enhance the real-time analytics into engineers and our safety managers with minimal training. So as a result, we will transform the 5 days high risk inspection process into a faster, fundamentally safer, and immediately more efficient solution.
Thank you for introducing it to us, Reina. I'm going to be talking about our design process for the line-fed inspection drone. And for this line-fed inspection drone, we decided that our one of our main priorities is going to be the high quality acquisition of data, because that's something through interviews we realized was going to be a very important part of this process, because that is something that drones can do very well, as well as 4K video for data acquisition. It'll take nice pictures and videos for you, as well as that will be combined with a LiDAR for 3D geometric processing, which will then be sent towards our places, and it will also not only tell you where the drone is, it will tell you where the infections are, and it will also tell you about any accidents that happen. On top of this, we decided that it would be very important to have an essential to have a reliable connection to the drone, because in these confined spaces and in these like very small pipes and everything, it's going to be very hard to establish a connection, have stable power, and extract these drones if something wrong does happen. And using this umbilical cord style connection, we will be able to provide power efficiently, have fast data transfer, and be able to extract the drone if anything happens. And finally, we'll also add a spotlight for visibility in dark environments. And then on top of that, for the end, we'll have a lightweight cage for protection of and further use of the drone.
So the next stage of this is the 4-phase predictive reliability program. The first stage is the detection. So we have an AI that will use the live feed and in real time detect anomalies using machine learning models such as convolutional neural networks. The second phase is visualization. We have a platform that we will show next that maps all the defects that have been detected along with images and descriptions of the defects. The third phase is the prescription of the remedy. So we have generative AI that will use information from the defects and prescribe a solution that can be used by the supervisor. Fourth phase is the agentic AI resolution. Once the supervisor finds the defect to be reasonable enough to solve, as well as the solution to be necessary, they can, with one click, automate the whole workflow. And so this is our demo. At the top, you can see the number of defects found in the critical defects, and it goes through the different segments, and there's a project progress tracker. And so by clicking on segment 2, we can see a location map that shows where each defect is, and you can see how the different details from the defect as well as the recommended action items. And once the supervisor likes the action items and they think that this is an ideal solution to have, they can mark it as significant and they can go through the workflow.
I'll be speaking on the impact of our solution. So with IntraLogic, we designed the Eagle package. With this package, we predict to produce 90% decrease in human CSE inspection hours and a 50 to 80% increase in maintenance efficiency. What does this mean? This means a potential annual benefit of $1.8 million a year. Does that say 1.8? I meant $1.8 billion a year for ExxonMobil. This is mostly due to a 50% faster data collection method, and a $9 billion amount would be saved over 5 years across the industry for Exxon. So you may be thinking, if it's this good, what are the total costs of the Eagle package? $20,000 per drone. You only need about 150 worldwide, and it's a $20 million deal with AI to set up the software with Microsoft, as Exxon already has establishments with. So go with IntraLogic and the Eagle package. The only way to prevent an accident is to not be there at all. Thank you, and do you have any questions?
IntraLogic, everybody. Okay, over to you. Who's got the first question?
Right. I again want to ask the tactile element question. So a lot of these inspections, you're feeling around on nuts and bolts, making sure things are tight. Do you see any way you could integrate something to address that on your platform?
Right. So currently our solution does not address tactile. We are purely a visual data acquisition device. This is because by understanding the overall turnaround method we still need humans to go in and perform the maintenance. And so by increasing or decreasing the total inspection time, we are still able to increase the safety and also the efficiency of the entire turnaround process. We want a solution, while it would be a great idea to funnel R&D into a solution that provides that, the time is now to improve current inspection methods our solution is technologically feasible, commercially viable, and fills a gap within the current safety methods.
So you have a cord that is attached to it that provides power and data. Now, for applying this to, let's say, staff or something, how would you get around some of the cord could create issues? Right. On trying to get through and navigate up and down.
So our solution works if and only if a human can also go through the same process, because again, we need maintenance, which, in case it's been a long time since you took Math 251, means that if a human cannot enter, our drones also should not meet or be over-engineered to meet those parameters. Humans that enter are still currently attached to a harness and tethered so that emergency retrieval is still possible. Why should this not be available for our drone that is still tethered? Currently in Ukraine, wired drones are used for fiber optic cable to prevent data jamming across the war zones. We believe that this technology is directly applicable to the specific use case, and coupled with the fact that we're providing power and an emergency retrieval process, our solution is the complete solution to your needs.
We considered X-ray.
X-ray. While we did initially consider retrofitting our solution with additional sensors, such as ultrasonic or maybe magnetic particle testing or dye penetration testing, we decided that visual inspection is the primary inspection method for all maintenance. Meaning that for the maintenance team, they can go through, conduct the highly specific ultrasonic testing, which requires a lot more technical capability and equipment, eliminating the need for our drone to be able to compatible with all these variable tools.
I very enjoyed that you bring a lot of the technical words using the AI automation. You actually, if you want to implement to EXXON mobile system, which kind of technology challenge you will have for them? You mentioned machine learning, you mentioned a lot of the AI, which kind of technical challenge you will have on the EXXON systems?
Yeah, so one of the challenges we saw was the infrastructure itself. And for that, we saw that EXXON already has partnerships with companies like Microsoft, Snowflake, and IBM for various aspects of that. Another challenge would be getting that data to initially train the models. That would probably just be mitigated by initially just having drones that do the surveying, but can't really tell you much information. And then we can use like supervised learning to kind of give you more effective analysis.
So when you're looking at AI do this, it's great for on-site, but like if I'm offshore on an FPSO and I'm doing a hull inspection down below, do I have to wait for the data? Does it get uploaded to via satellite, or how does the data get to where the processing happens? Get my report.
30 seconds to answer, please. 30 seconds.
Sorry.
So no, I'm just letting them know. You got 30 seconds, please.
Yeah, so I believe we saw ExxonMobil is also partnered with Starlink, and so we would use the existing pathways to get the data and be computed.
Good. Yeah, pardon the interruption. I just want to let you know you had time. Yeah, let's give it up for him one more time. All right. Everybody, I forgot to mention, this is David, and my life would be empty and meaningless without him. I just want to say thank you for making this happen. David's part of the team here at Malloy. Can we give him a round of applause? All right. And they're already on it. They're coming up. I got to check it out. Yep. Delta Drop is the next team. Yeah. Come on up to the front. You guys good? Did you? Yeah. Everything good here? Okay. Thank you. down is forward.
Yes.
Up is back. Good. Good. So whenever you go, I roll straight.
Hi everyone, we are Delta Drop. We're gonna start today off by showing you a small video about our problem.
The world runs on water. Nature, life, industry. Across the world, water is used in industrial operations that create the fuel and products that make our lives reliable and comfortable. That water comes from our cities, lakes, and rivers. And to meet certain standards of safety and quality in industrial systems, this water is cleaned and treated. The water is then used to cool various machines and chemical processes, taking on the heat produced by these systems. This now warm water is then processed through cooling towers to be reused. But during these industrial processes, we lose a lot of water through evaporation in water towers and blowdown to preserve water quality. Since water is lost in these operations, it needs to be replenished from freshwater sources. According to estimates from the US Geological Survey, trillions of gallons of water are used across the country's industrial cooling systems each year. That is trillions of gallons being taken away from our shared source of fresh water, which is vital to health, agriculture, and the livelihoods of each and every person in the world. But there is a better way. Let us introduce Delta Drop. Join us in exploring a new system for water conservation and industrial cooling, because together we can change water.
Awesome. So hi again, we are Delta Drop. I am San. I'm going to take a second and allow the rest of my team to introduce themselves.
My name is Saket.
Hi, I'm Pradak. Hi, I'm Hadley.
Howdy, I'm Kieran.
Hi, my name is Adarsh.
And today we're going to start by talking about an issue that affects all of us. The world is facing a drastic shortage in fresh water supply. Fresh water is a resource necessary for all modes of life and society. In fact, one of the greatest demands of fresh water is industrial cooling systems. These systems that make our lives accessible and comfortable. Industrial cooling systems use about 39% of the entire world's fresh water supply every year. Most of this water is lost through evaporation and blowdowns, which are necessary processes to make sure that products are of high quality and that equipment is not destroyed during the creation of these products. Our goal as a team is to develop a solution that balances the need to meet this demand while maintaining environmental and financial sustainability. And to succinctly give you a high-level statement for our need, we're going to be tackling conservation of water and industrial cooling systems.
So taking that need statement into account and connecting it to ExxonMobil's AIM equation, which involves meeting society's needs for energy and essential products and reducing emissions, we decided to come up with 5 design requirements that would help constrain our research and essentially solution-making process. So we focused on actually making sure that whatever solution we choose conserves water. And then we really want to ground our solution in reality. So we focused on how feasible each solution would be. So focusing on cost, power efficiency, and also installation time. Finally, we also wanted to see what each solution's environmental emissions would be if we were to implement it.
So taking these design requirements into consideration, we came up with 3 solutions that we hope would attack this problem from 3 different standpoints. The first solution we came up with is detecting leaks in heat exchangers and developing a coating to use on the inside of pipes. The main solution that this would be addressing is that we would be reducing the amount of contaminants in the water, which would decrease the amount of blowdown we'd have to do. But the main issue is the time for installation, which is projected to be around 2 years, which we deemed was too long to stop processes for. The next solution that we thought of was hybridization, where we would implement a dry cooling system with air in addition to the water cooling system. But this also had some issues, as the cost was projected to be around $13 million for the initial investment, and it also required 1 year for installation. On the other hand, our final solution that we finally decided on was steam recapture, and this only required around 1 month with our estimates to install, and also met our water conservation goals really succinctly.
So to better understand how steam recapture works and why we choose it, let's compare it to the base case scenario. So standard cooling tower operates consuming a lot of water to heat industrial cooling processes. The water is absorbed by heat and released as a vapor to the atmosphere that is completely lost, creating a need for more freshwater supplies with a demand of blowdowns to control the water quality. What we offer as a steam capture technology, we have a system that we put on top of cooling towers that captures all that water that will otherwise will be lost to the evaporation, and reuse it as a system of closed loop cycle, minimizing weight and improving overall sustainability.
Right, so recognizing that there are a lot of steam recapture technologies that do exist, but some are very efficient and some simply aren't able to really solve problems we do a lot of research and I think we came across one particular solution from an organization called Infinite Cooling that works. So right here we have a standard cooling system which has evaporated water coming out of it with a visible plume of steam coming out of the cooling tower. We think this solution that we've been able to find in research will be able to solve that by retrofitting a system that can take that steam and turn it back into reusable water.
So the first step of this retrofit is to have a grid that we would place in the way of the water plumes. And this grid is made up of ions that allow us to positively charge the water vapor that is coming.
So that positively charged water vapor then enters a series of vertically stacked meshes. Now this is the heart of technology. This is the water panel technology that is utilized in this process. So these are all charged with a negative charge. So the positively charged water meets the negatively charged mesh. That creates an electrostatic bond, which allows the actual steam condensate into a liquid water. Now, as the steam continues to enter the mesh, more and more water is able to condensate, and a film of water is able to develop on all the meshes. As the film develops and becomes thicker, gravity takes over and naturally lets that water fall down into a series of channels. Those series of channels then feed into a single pipe of clean, reusable water that can be sent directly back into the cooling system. Now, this is still a very relatively new technology that's still going through its conceptual phase, but we have seen
at a 3-cell waste management plant located in Pennsylvania, just like the industrial cooling system at EXXON, they were faced with the problem of high water demand, especially freshwater demand, for their cooling towers operations. But after a quick 3-week installation with no stop to their production, they were able to bring down their water by 1.3 million gallons in just a year. Coupled with this, in a year, we saw a 4,000 metric tons of carbon emissions reduced. This case study also solidified that these panels were built to last at a minimum of 20 years with a low maintenance cost kept in mind.
Comparing this case study to a facility without these panels, we saw across the board a reduction in water waste, in energy usage, and in carbon dioxide emission. 25%, 9.5%, and 10% respectively. These numbers meet all of the goals that we set for our environmental design requirements. However, I'd be remiss if I didn't discuss our cost savings. So, using the 25% water savings and scaling it to one of your facilities, say 34 cells, we found an annual savings of $2.6 million, an annual expenditure of $350,000, and we assumed an average of 8% interest per year, and we found a payback time of 2.5 years. Furthermore, we projected that a single facility would save $17 million over the next 20 years.
Considering this incredible economic benefit as well as the very apparent environmental advantages of steam recapture, it becomes very clear that steam recapture is a viable and attractive method for water conservation in industrial cooling systems. So we invite you, ExxonMobil, to come join us because together we can change water. Thank you. I will take any questions that you have now.
Judges, who's got the first question?
I guess rewinding to your projected benefits, I was just thinking in terms of the CO2 reduction that your solution claims. What's your basis for that?
So we were looking at multiple factors. So the reason why we kind of went with this solution is we saw that it has been somewhat developed a little bit. We've seen it used in other kinds of similar system over there. So it looked like what we found from the data is that they looked on the actual plume that was being created from the water tower. So kind of the general consensus that we see that nasty plume. I mean, people don't know that's just steam. People think it's something else that actually is picking up, like it's some sort of smoke, some sort of other byproduct. So with this product, it not only does it completely remove the steam, the plume that you became, that plume that would have been created that could have maybe been carried on to other parts of the either facility or just out in the atmosphere that would have picked up other kinds of other gases or some sort of other materials or particles in the air. Since now we kind of fully eliminated it or eliminated to a certain degree, the overall emission of the facility we saw kind of reduced to 10% per se. Now this was still kind of a theoretical value, and you're seeing how it only applied to the power plant physically, and you have to see how it applied against on mobile. But that was kind of our basis on how we saw a 10% decrease, and that's mainly I think explanation of how. And that's why we're mainly just trying to see if we can find a data and a number for everything, so we can see how feasible the solution would actually be if EXXON if implemented. And that's why we went with it.
So on the energy use, so you have a reduced energy use. Where is the energy being reduced? Like, what's causing the energy to come down? Is it not having to pump the water in? Is it not having to work as hard on the water? I'm just trying to.
It's exactly that with the water pump. Since we are returning back, we're using kind of more of a gravity system instead of forcibly pulling. So the direct energy savings does come from the lack of use of the pump as often when going through the makeup water.
Add those into the CO2 calculations as well, because reduction in energy should reduce my CO2.
Yes, that's where we see the majority of where the CO2 did decrease was because that pump wasn't ran as often.
Other question. So that plume for a large facility might have their own wastewater or stormwater collection. I can see how this would be directly useful for a facility that doesn't recollect, outside water from rain for use in their facility. Does this have a direct benefit for a facility that would collect rainwater to supplement their water supply?
So this system takes the evaporated water that is clean, that is pure water molecules, no concentration within it, and makes it condenses it and redirects it back to the cooling system. The thing that the wastewater probably has some concentration of minerals, some kind of salts in it that will damage our equipment. But with this system, we say that the water is entirely pure, and we don't spend money on treatment, on cleaning, on it. So that's why.
That's a good point. Thank you.
I guess to build on, sorry, right here. So kind of this is another support of our data. They had a case study that was run on where they looked at the overall collected water from the system, and they compared it to wastewater, and they looked at the overall chemical composition of wastewater, and they saw pretty much 100-150% decrease depending on which chemical you're specifically talking about in each one of the major chemicals in the collected water as compared to the wastewater, with such as potassium, sodium, substantially lower numbers than what we found in wastewater. Help prove that it is very clean water that would require minimal to no treatment on the actual water that's being sent back into the system.
And this is also another factor that we considered while looking at the reduced CO2 emissions, as not having to filter water would reduce all the power we use in filtration processes, post-filtration, pre-filtration, all those processes.
Time for one more question, I think. If you have one. No? You good? Say hi to your wife. Put your hands together. Excellent. Folks, he likes to keep a low profile, but right over my right shoulder here is our man in Marcom. It's David Cook, the man with the camera right here, and he's going to be taking a group
photo on the stairs when we wrap up. I'll have more to say about that as we come to our closing. But please, after the competition is over, we want to get everybody on the stairs with that Malloy logo in the background. We're going to take some pictures. We'll have more to say about that when the competition is over. But right now, we want to turn it over to our 8th team, and that is Operation Halo. Let's put your hands together if you don't mind. Down, make it forward. A little bit of a shift, a little bit of an audible. Okay, guys, you ready?
Worker is dead after a crane accident at a construction site in Northwest Austin this afternoon.
That construction worker crushed by a forklift as he worked in the
Investigation is underway after a deadly accident.
Story, a man is dead after
Federal
a forklift
investigators
accident at a business.
Howdy, we are Operation Halo. I am Ryan Wynn.
Hi, my name is Sahitra.
I am Tara Aarti.
My name is Arun Vaidyanathan. I'm Shiva Mishra.
And I'm Naomi Lamaji.
1 in 50 oil and gas workers suffer an injury from collisions with heavy machinery every single year. I want everyone to take a second and look around the room and take an especially good look at your neighbors. According to statistics, if we were oil and gas workers, at least one of us would not make it throughout the year, whether it's due to death, amputation, paralysis, and way further more. This is all simply due to a lack of awareness. Now, why are we not aware? As you saw in the video at the start, the forklift operator couldn't see the 7 people that were standing right in front of him just because of those blind spots. What we need is a comprehensive system that not only tracks, but also alerts personnel and people in the oil field and stops heavy machinery before the accident occurs, while also not interrupting production flow.
While developing Halo, we knew that our solution had to be adaptable to different kinds of oil and gas sites. This includes offshore, onshore, upstream, and downstream. We also knew while prototyping that our equipment would have to be adaptable to different rotating rental equipment or climate and weather that's unpredictable, like icy rigs or dry and dusty fields. But after having these ideas in mind, these are the 5 design requirements that Halo revolves around. So first is the automatic stop system, and then next is its adaptability in extreme conditions, its reliable detection software, its affordability, and then its plug-and-play integration that allows it to be integrated into any kind of machine.
When we started researching the industries on how they were trying to tackle the human intervention with heavy equipment, we got to know that some companies still do it manually. Like there will be a worker who is standing beside the operator and signaling. And some companies were incorporating 2 technologies, which is RFID tag and LiDAR sensors. As we all know, RFID tag is very cheap and is easy to install and use. But we all know it lacks a visual awareness, because of which it is completely not reliable. When it comes to LiDAR sensors, It improves the performance by precisely sensing the human with the heavy equipment, but it is costly and it's also very difficult to install in hundreds and thousands of heavy equipments. Since both the solution doesn't meet all our design requirements, and that's where our product Halo comes into play. Halo fuses the use of 360-degree camera with ultra wideband tracker, which is trained on a custom AI model, which ensures that all our design requirements are met. I want you all to look into the design requirement very keenly. We are not trying to just detect the humans, but we are trying to protect even before the accidents could even happen.
So this brings us to our prototype, and in front of you guys here, you can see a model of a scenario using the 360-degree camera. So right here is our camera system, and here is a worker and a forklift. And as you saw in the video, the forklift has many blind spots, and the camera system, which we demoed at the end of the video, can detect the forklift and the person, and it can estimate the distance between the two, and given a buffer zone around it, it can stop the forklift if needed. And the second part of the trigger is going to be the smart hat. So the smart hat involves the ultra wideband tracker, which is worn by the worker at all times, and the operator inside of the forklift or other heavy machinery will have a wristband, which will transmit a signal and measure the distance between the worker and the heavy machinery. And in the event of an emergency, a signal will be sent to this transmitter, this receiver right here, which is a J1939 port, which is found on many heavy equipment that's used in the oil and gas industry. And this will use the OEM auto stop function, and it's plug and play for multiple rental equipment and contractor friendly. So when you get to a work site, it's easy to set up and move if needed. So such as in an upstream application when work sites are moving every couple months, when you need to set it up on new equipment, it's also available there. Another aspect of why we have this two trigger solution is for the consideration of cranes. Cranes are huge, and a simple ultra wideband tracker between estimating the distance of a person and the crane is not useful because the end of the crane or the rigging on the crane is more dangerous. So that's why we needed the camera. And the camera alone is sometimes not useful when it comes to extreme outdoor conditions and a lot of smaller machinery is in use. So the ultra wideband tracker will send a signal to this transmitter or this receiver. And right now, the first demo, the camera was shown in the video, and our second demo with the ultra wideband tracker will be shown right now.
So, for example, if we are not utilizing the camera in this application, we'd be utilizing the ultra wideband tracker. I, for example, would be a forklift. Tara is a worker. Somehow Tara ended up in my blind spot. So I'm moving towards her. And as you can see, in real time, it's actually tracking the proximity between me and Tara. If I get close enough to her and to the buffer zone, which is fully customizable, it will play a ring. And if I get close enough, our AI system will actually stop me, the forklift, using that universal plug-and-play module.
So Halo, our AI model Halo is completely offline, runs completely offline, and uses a self-supervised AI training model. Our AI model is trained on a data set of 3,500 images, and Halo's AI software is ready to incorporate ExxonMobil's data on cranes, forklifts, and other heavy equipment.
Our product Halo has 5 key components, which include a camera, a custom AI system, an auto stop module, along with our smart hat and our smart watch. We estimated that the cost of per unit for all of the 5 key components would be $339 per unit. And with bulk orders of 100 or more units, this cost would be reduced to around $261 per unit for the average of 50 units per site. Furthermore, with the implementation of Halo, we estimated that site efficiency could be improved by 15 to 25%. But at the end of the day, saving time is not all that matters. We care about saving lives. Remember, 1 in 50 workers every year on an oil rig in the oil and gas industry are involved in serious or to fatal injuries every single year. Our goal is to bring that number down to 0. Halo stands as a safeguard so that every worker will be able to go home to their family safely at night, which is what really matters. Thank you.
We are
Operation Halo.
Operation Halo, everybody. Judges, over to you. Who's got the first question for Operation Halo?
So it's a camera system, a 360 camera system. Does each camera make its own decision, or is it going back to a central hub that is then sending, how is the signal logic wiring going?
Yeah, so each camera would be making its own decision. So since it's run entirely offline, the AI program would be running on an edge compute unit, and the camera would be connected to that. So the video stream is sent directly to it, and based on the decision made by the compute unit, it will send a signal directly to the receiver that would be plugged into the machine.
What happens? So I'm assuming you'd have multiple, for a large facility, one camera would not suit the whole facility.
Yeah.
And so the cameras would possibly overlap.
So we also took that into consideration. So one of the reasons that we wanted a 360 camera was the different mounting positions. So since we wanted to be super modular and adaptable to every type of work environment, on an upstream facility, the mounting position for that would be convenient there would be magnetically mounting it to the top of equipment. So the 360 camera, we wouldn't need many of them across acres of land. But in a downstream facility where the refinery is already set up, we can use existing CCTV camera sources or set up cameras there if needed.
You estimate the cost for your solution. Can you compare with the other existing solution, this solution? RFID or
RFID, in terms of cost?
yes.
We used our data. The way we came up with our cost was through case studies of similar implementations of AI systems, but not using the same tracking system. So we cross-reference that, and then also we consider the cost of international shipping, how the reduced cost the cost would be reduced to ship in bulk and also through international shipping, and we factored that into our estimate of what our cost would be.
I'll add on to that. The RFID chip, it's much more affordable, but with that, for example, an RFID chip, it's just tracking, right? So for example, someone could be riding on a tractor. If you're that close and you're riding on the tractor, what will happen? Will it stop the tractor? Versus this camera, we can actually train the model itself using different pictures. And as you go on, it actually learns itself. So if you have someone riding on it, and you can confirm that, hey, he's riding on it, you need to stop the operation, the AI model can continue learning, and it will not hop processes if something like that occurs.
So you feel that your estimated cost is affordable, right?
Yes, we believe it's affordable, and we think that the solution that it provides is also very good.
You also mentioned it's plug and play compatible or with a lot of different machinery. Is that your software in the module that enables the automatic stop, or is that something you think that a lot of heavy machinery has built in already, is the automatic start and stop?
Yeah, so the equipment is required to have an emergency stop function. It's part of the ISO standard, and I believe it's 21815. And in that standard, all of the equipment must have an emergency stop function, and they also must have a remote stop add-on available. That varies by manufacturer, but with this port connection, we are able to use our custom software and interface with that.
So what happens if it loses communication to the camera? Does it just stop the machine, or?
Yes, we would integrate a failsafe for that.
And also, that's also why we have another failsafe, which is the proximity trackers. So that's also used for in rough conditions, say if there's poor visibility, right, the camera might not be able to see. So that's why we implemented the tracker in case of something happens.
One more question, if you have one. Less than a minute left. 1 second. We good? One more round of applause. as the judges make their calculations, our next team is R3 Dynamics. Be thinking about the prototype that you've liked the best, the presentation that you've liked the best, the video that you've liked the best. This is a tough competition. Wow. Thank you for bringing your A game. We're not done yet. One more group. Let's hear from R3. You guys all set? Good? Whenever you start, the timer starts. R3 Dynamics, everybody. Let's give a round of applause.
Howdy.
Howdy.
So we are R-Cube Dynamics. We are here to talk to you today about reducing water waste in industrial cooling systems. So we've got a little bit of a video prepared ahead of time, so we'll go ahead and play that for you now.
Oh, it's down there. Down to go forward.
So, will Corpus Christi run out of water? That's the question we're confronting in this new series.
For the hot story tonight, Corpus Christi is running out of time and out of water. Our western reservoirs are drying up fast, and city officials continue to look for new sources before the taps start running.
What Corpus Christi residents are asked to do: conserve, make every drop count. But industry doesn't play by the same rules. Industries account for 60 to 80% of the city's.
We know that no other publicly traded organization cares more about maintaining a positive reputation and caring for the environment than ExxonMobil. That's why we at R-Cube Dynamics are willing to work hand in hand to find the best solutions we can to maintain both those goals.
Going forward, running out of water is a terrifying aspect for a lot of reasons. We drink it, it's used in industry. I know you at ExxonMobil, you use that for your industrial cooling system. So if you have none, you can't do anything. So this is becoming a very big issue. And a lot of this water is being drawn up through industrial cooling towers. And I'm talking in the magnitude of millions of gallons that are just wasted each year through inefficiency. That is a big problem. And we at R-Cube Dynamics are absolutely able to make a difference in that. So, to give you a little bit of a rundown on what we're thinking here, let's take a look at a diagram of how these industrial cooling towers work. You've got a source of water that goes in, it's cooled down in the tower, and it is then run through to a heat exchanger, which is depicted here. That water is then heated up, recycled through the system as many times as it can be in essentially, ideally, a never-ending loop. Unfortunately, that's not the case. There is a section here called blowdown. Blowdown essentially refers to when you have certain conditions that are met where this water cannot be recycled. So that, namely, is if the water is too hot to maintain that circuit, it needs to be vented, new water needs to be brought in, and the temperature is equalized. Or you have sediment buildup that causes scaling and corrosion, which will damage your internal systems. So if those two things cause a lot of this blowdown process. It's an inevitable thing, it's gonna happen, and we figured this is the best place to start tackling this water situation. So I'll turn that over.
When looking for a solution to minimize blowdown water waste, we looked at 5 design criteria: water efficiency, ease of installation, overall cost, heat reduction, and scaling and corrosion reduction. When looking at water efficiency, we're looking for a solution that meets a criteria within the metrics that decreases the water waste produced by blowdown in gallons per year. When looking at ease of installation, we want a solution that's modular, can be easily installed worldwide across hundreds of refineries and industrial plants. When looking at overall cost, we're looking at a solution that minimizes cost while maximizing performance and efficiency. When looking at heat reduction, we're looking for a solution, like previously mentioned, reducing the heat of the water, which means we can cycle it through more without having to vent it. Same goes for scaling and corrosion. We want a solution that minimizes sedimentation buildup inside of heat exchangers and prevents us having to blow down and get rid of that.
So keeping this all 5 design criteria in mind, we have come up with 3 novel solutions. So why we waste water? Why is the flow down? It is because water is heated so much that it can't go again in a cooling tank. So our first design introduces a chiller. If we introduce chiller after heat exchanger, it will cool down the water so that it can again be used in a cooling tower. So this will be like closed loop system. Our second solution addresses the problem of sedimentation. As there is sedimentation built up in a water, so that we can't reuse in our cooling tower. So we introduce a purification process in between so that we can again use it in our cooling tower, and again this will be like closed loop system that you are looking for. So in our third system, we have three ideas combined. So instead of using chillers for cooling down the water, we have increased the efficiency of heat exchangers itself. That is one idea. Another one is if we have looked for the other processor in a refinery where we need heat. So we can circulate that water to that system such as crude oil so that it will be like cooled again, and then it can be recirculated in a cooling tower. And another benefit of this system is we are introducing automatic flow down valve. So right now the flow down water that goes down, that is done manually, and due to manual errors, there is like millions of water wasted. So this issue can be addressed with the automatic valve. So comparing all these three designs based on our 5 design criteria, we have come up with decision metrics.
So to decide on the decision, we look back at the 5 decision criteria and we ran them through the decision matrix. And basically, we figured that optimizing the heat exchanger would be our best choice due to being the most efficient and saving water. It's easy to install throughout all refineries, and the overall cost is the most affordable while still being balanced well and reducing heat and the scaling issue.
All right, so I'd like to go ahead and give you all a better qualitative understanding of our optimization here. What better prototype is there than Legos to display the modularity? It's plug and play. Our design is all about based on infrastructure that's currently there and low implementation cost. Our first novel design is we're going to go ahead and take the valve automation and monitoring system. So we have implemented 2 temperature probes that will go in before and after heat exchanger and help to automate when we blow down this water. And that'll help to improve the timing, which will help reduce the water loss during blowdown. In addition, our monitor system will help improve the accuracy of this timing system over time. Over time, it'll get much more accurate. Then the next problem we tackled was improving heat transfer within our heat exchanger. What we found is that we could actually innovate the heat exchanger design. So we took the shell and tubing within, and we oriented the tubes within the shell much differently, such that the surface area of contact was much higher and increased our heat transfer rate. And this allowed us to bring cooler water out from the end of it, and we could put that back through our cooling tower with much less stress to the cooling tower. And then finally, judges, I know we all have a strong understanding of chemistry, but for a second, be alchemists with me. We're going to turn our waste into gold. We're going to use this hot water coming out of our system, and we have a bunch of other systems in our refineries, such as heating up crude oil, heating up our boil or feed water, that we need to heat those up. So we take our hot water and we cycle it through those systems so that our hot water gets cooler while our other feed water and crude oil are getting warmer. And we bring it back. We've saved water, we've saved energy, we've saved fuel, and we've used our waste heat.
I'd like to talk about some impacts. So increasing heat transfer and heat exchangers. Yes. Increasing heat transfer and heat exchangers, it was discovered that we can reduce changes in heat temperature by about 10 to 15 degrees Fahrenheit, thereby enabling the reuse of the water in the pre-existing infrastructure, therefore reducing the blowdown frequency by 50%. In addition, there's the metric of cycles of concentration, increasing from 3.6 to 6, which can be interpreted as using the same water for nearly 2 times the cycle. And last but absolutely not least, by utilizing external heat exchangers, which run on natural gas, we are able to move some of the hot water and supplement the natural gas, thereby not only reducing the water temperature even further, but using less natural gas, therefore reducing carbon emissions.
So to put this in a little bit of a more bite-sized perspective here, average industrial cooling facility is going to chew through about 720 million gallons per year. That's a lot of gallons. And this is the water lost through blowdown. But if we implement this very small change using existing infrastructure at minimal cost, we can actually knock this down to 360 million gallons per year saved, which is about a 50% increase, or 50% decrease in the amount of water that we waste. That's a pretty substantial amount, and that's annually. So this is going to stack as we go. So I guess the last question I have for y'all at ExxonMobil is, are you ready to retrofit? Thank you very much.
R-Cube Dynamics, everybody. Who's got the first question, judges?
So the exchange happening is the, I guess, cooling water that you're trying to cool down further, and you're exchanging it with crude coming into the refinery.
So is that in reference to the combination solution?
Yes.
Yeah.
So this process, there's a lot of processes at the refinery that need heat. Like our cooling water, we want to lose heat, but some of the things coming in, like our crude oil, needs to be warmed up before we can do stuff with it. And this is normally done through like furnaces and stuff that use natural gas. And so what we're suggesting is that we take our hot water from initial stages and put it through that to heat that crude oil up while decreasing the temperature of our water, which eases the strain in the cooling tower and eases the strain that we put on natural gas for the furnaces.
So optimization. How frequently you run optimization? How fast the optimization give you a solution?
I'm sorry, do you mean like how fast can we implement it?
Run optimization?
How fast we can implement our solution?
Then you run optimization, the other optimization system.
So to give an amount, kind of an idea of scale that we're talking with here, during the summer months is when this blowdown process is going to happen the most. That's when things are going to get hottest. That's when things are going to, need to be changed out. So that's being run based on some estimates that we got about 50 days a year, all day. That's a lot of data points that we can collect for this. So depending on how much data we get, that will determine our optimization. But there's going to be a lot of instances where we can start collecting this, build a model, and actually be able to predict this.
I would also like to add that that data comes from some of the vendors we found online selling cooling towers, and we've upscaled that to some of the facilities in, for example, Beaumont, Baytown, and Baton Rouge.
Does that answer your question?
Yeah. Okay. So you get the data, right? Your history data, and then you run optimization. And your model will be data-driven model, or you want to use a rigorous model, a physical rigorous model.
Maybe it's not a data-driven model. It's like we have calculated some like delta drop of the temperature through our heat exchange equations, and we optimized our heat exchanger based on the surface area for the heat transfer. So if we increase the surface area for heat transfer, so that we can use water efficiently for the temperature drop for other processes. So that way we are saving water.
So for some facilities, cooling water actually might be the coldest stream in their facility, meaning if you're looking for things to exchange it with, you might not have an option. Even their crude might be hotter coming in than the cooling water. Did you all look at any other mediums maybe to exchange with other than refinery streams, like bringing a tank of coolant or something that could make
Yeah, we did look at that. That was actually initially sort of what we built the idea off of, was having something else that we could run this with. So maybe using something like a propane based kind of system. So there's nothing to say that you can't do that. We're just trying to look at what we have like readily available in some instances to prevent y'all from spending more money than you have to. Just kind of, like you said, turning lead into gold.
Just to add on to that, we have looked at the chiller options. So problem with the chiller options is it runs on refrigerant, and again it needs energy, and also cost of installation is a bit high. And we examined that this problem is generally occurs in the summers, so it will be like kind of short span. So rest of the year those chillers will be idle. So we thought it might not be the like feasible or optimized solution. So we came with the other.
So in the optimized solution, are we saying that we can get more circulation like 3 or 4 times?
So with the optimized solution, we're essentially saying we're optimizing the contact area of tubes within shell and tube heat exchanger. So we're essentially taking the baffle and we're putting more tubes in there while reorienting them, so we can take up more of that surface area, and that's essentially going to run more water for around the same amount of oil. So our water is in turn coming out cooler than it would be if we were running a traditional baffle system.
And just to add on to that, that's going to lower the amount of times that we need to do that blowdown process. So in turn, yes, it's going to do that.
Okay. I think that's time. Thank you very much. Well, that completes the competition part. Thank you very much. That completes the competition part. And Professor Fred, if you're back there, we want to put that QR code. Thank you so much. He's on top of it. Congratulations to all the competitors. Hi, are you coming up here to talk to me, or you get? Okay, go to the important stuff. This is the survey. Please take out your phone, hit that QR code, contribute your insights, your observations. There are several questions in there, and we will be giving out awards and recognition for things like best video, best prototype, the things that you see on that link. Our judges, if you would please move into the room behind us here with David. I'll join you shortly in just a second, and we will have hopefully just a brief deliberation, and then we will come back once we have tabulated the winners. We will start our remarks with the People's Choice Awards, the awards that you're going through and taking care of right now. And then we will move into the other awards, not the least of which is leading to today's first prize award of $5,000. I'm going to step into the judges' room right now. We'll be back shortly. Please stay in here. And then once everything is wrapped up, I want to invite you out into the hallway, and we're going to connect Mr. Cook on the steps, and we're going to take a picture for posterity. And of course, our mentors are going to be involved in that as well. As you come up and the winners are announced, we will take pictures of all the groups. And then, since we've assigned mentors to each a one-on-one, can we get the mentors to step in and get a snap of that? Is that cool? Will you guys be up for that? That way we can have the mentors to the teams that you're assigned. Very good. I'll be back shortly. Take your time with a survey. See you in a minute.
What he was asking was how fast are we going to be able to have like a model ready to go?
Kind of like
The reason I was saying that, I was watching the clock and I was like, oh, it's not going to I was like, I know what I have to say. I appreciate that. I just you nailed I can tell you exactly.
Yeah, in my head, I was like, I speak that.
Like what, 4 seconds left of the
And we had like this HR that was in charge of the law. So if there was any she had little teams. So I just let the in a team. She went
AI.
could be used more than Does this have an audiobook? Certainly is in the green polo back there.
He's already left.
Use the make it my lens is actually you're not in my
Culture, dude.
I have video of the videos. I don't you're gonna be true, but it's not something
Okay, leave some drops in the
you contact David afterwards. I got you. If you're like, I can always text me. I should just add your email. Just all right. This all agrees.
right. If y'all want to make this look good, let's do that. That way we got everybody on there. Good. Let's see the king of this.
I feel like I messed up on my part, but then the question I was like, I had to come back and I thought they were gonna kind of hard on us. What were the questions?
Alright, let's see if we can fit everybody on there. Alright, we're gonna do this. Let's scoot in on the banner here.
Your mentorship. Let's take our seats. Let's come back. Let's come back to a single conversation. Please take your seats.
That's impressive. They couldn't even get my size right.
Okay. Just check.
This is all right. Here we go. Fred, are you back there? Whatever that is. Put something up there for me. Are we ready? Wow. What a day. I'm going to go out on a limb. Actually, it's not a limb. It's just a fact. This is the best Aggies Invent I've ever seen. Woo! I'm very, very with the judges. And if you don't mind, I want to take a moment before we announce the winners to have just a moment of feedback from the judges, because what they saw, I think, is really, really valuable. And I've asked them to be brief, but I want them to share in general terms what it is that they saw today, what it is that they liked, what it is that you were getting right, and what it is that you are doing that compares to what they're seeing at the largest publicly traded energy company in the world. Okay? Would you like to start us off, Sarah? Could you please turn and face the students and just tell us a little bit about what you saw today?
Sure. No, yeah, I would say what I was most impressed with, I really loved the videos. Very impressive, very compelling, great presentations, great ideas. So I was very impressed.
Thank you. James.
So next, I guess, great job to all the teams. I was really impressed with how it seemed like everyone really did a good job thinking about the feasibility and the scaling of their idea, just to make sure, like, you know, as we're going through thinking about it, it's pretty much every team was like, yeah, I can kind of see this making sense in the real world. So really excellent job. Say on the constructive side, as you're building your presentations, just a bit of advice for the future. Maybe think about, for your audience, what's going to be the first question they're going to ask after they see your presentation. Try to answer that as you make your presentation. And then that way it just helps you connect, kind of read their mind as you're building your presentation, and just increase the quality of your pitch. But really, really awesome job, everybody.
Yeah, I want to say awesome job. I sit through 5 million presentations a year, I believe, and these are some of the top ones. I want to say y'all truly know how to make presentations. The videos were by far impressive, but the data, I want you, I mean, you don't know how many times I have to tell people 20 years out of college going, less information on a slide. If you can talk to it, use key points, and y'all did amazing, and keep it up, because that sets you apart from other people in the industry. And if you want to grow your career, being able to use your slides to speak and not just putting information on a slide is going to be the key to moving forward.
Thank you. For me, I really appreciated everybody. I really like all the videos. Way better than I can generate. That's just so good. Maybe you're using the AI, whatever you use. That's so good for videos. It's so good. I asked a lot of questions. I needed to get your answer. Answer's good. I want to see the collaboration. I want to see if someone can answer the question, and then your teammates also help you to answer the question from different sides, different kind of perspective. I really appreciated that.
Judges, thank you very much. Now we move to the awards portion of the thing that you've all been waiting for. And as you are called for awards, and I think we do, we take pictures for all of the awards. Yeah, so if you will step up here, we'll take a picture of you. And for the top 3 places, the top 3 winners, we'll take a picture of the team, and then we'll ask for the mentor to join as well. All right? So first and foremost, our most feasible solution goes to ThermoLink. ThermoLink. Okay, they don't want their picture taken, I'm guessing. Oh, they do. After all, they do. Okay. I didn't know if you're camera shy or what. Shall we stand right here? Come on. Wow, I've never seen people move so slowly. You get their picture taken. This is surprising.
A little bit over this way. Just
there you go.
Get everybody. All right. 3, 2. Perfect.
Excellent. Thank you very much. Everybody. Most feasible solution. Next up for best prototype, put your hands together for Delta Drop. Delta Drop, best prototype. Yeah.
This is my
Let's get in here and get our picture taken. I'll eat first. Wait just a second.
Yeah. Over this way.
Oh, sorry, we're too far. Yeah, here we go.
There we go. All right.
Yeah, I might even give it a good smile. Is that okay?
Yeah, go for it. 3, 2, 1. Perfect.
Excellent. Great job, everybody. Best video. Probably the toughest category today. Best video. Who do you think won? Best video, Operation Halo. Congratulations, congratulations, congratulations. Great job. Can we all fit?
Yeah.
Are we good? You got us in there? We Frank? Here we go.
3, 2, 1.
I'm the only one throwing it back.
There you go.
Yeah.
2. You got everything perfect.
Don't leave me on an island, man. All right, great job. Wow. Best video. Oh, guess what? It's time for the overall prizes. You ready? Third prize. Oh, guys, wait. Hold on just a second. Right there before you sit down. Third place, Operation Halo. Come on back. You know, that looked better on you than it does on me. Hold that up. There we go. And what we want to do is make sure that that check is straight. Does that sound good? I guess I can stand it. You're perfect right there.
Yeah, all right.
Check straight.
Bring up this.
There we go. All right.
3, 2, 1. We don't have to worry about the gig. You're good.
No.
You got it.
Somebody throws up the thumb and they drop the check. That's not good.
All right. Perfect.
Great job, everybody. Congratulations. That'll take you to Fuego. Am I right?
We do need that check back.
Oh, yeah, you can. Look at the money. Yeah, they were headed to Bank of America. It's stuck in the drive-through. Second prize is $2,500. Put your hands together for EXXON. That is for you. Yeah, you earned that. Come on up. Right in here. Look at that.
Yeah, you gotta
Yeah, guys, get in there. Get in there.
All right. Let's see here.
Excellent.
All right, now let's. This side seems to be the problem.
Look at this.
All right, there we go. Perfect.
I love it.
3, 2. You know what? Boom.
All right. Great job. One of the things that we did is that we assigned mentors on a one-on-one basis to each of the teams, and I believe one mentor had 2 teams. And so I want you to put your hands together for our first place winner, and as you come up, I'd like for their mentor to come up as well, please. Please put your hands together for our first place winner for Aggies Invent, ExxonMobil, Delta Drop, $5,000. Come on up. This is the big. Wait a minute. Oh, look at that. Can you believe it? How's that feel? Right back here. Here we go. Backing up. Yeah. Well,
Everybody get in.
hang tight. Yep. Everybody get in there. Oh, yeah.
All right.
Yeah, let's
Ready?
yeah. Stan, put a hand on it. There you go.
Okay.
You step in so you're ready. Yep.
Raise this side up.
Yeah, there it is.
Hold it right there. Right there.
Wow. Everybody smile and say first place.
Yeah, there you go. 3, 2, 1. pop that corner up just a smidge. Perfect. All right. First place.
Wow. Congratulations. You bet. You bet. Well deserved. Way to go. You know, everybody did a great job. Thank you so much. And thank you, mentor. Yeah. Okay. And we also have something a little special that we wanted to do because the mentors were so involved. We wanted to recognize all of the mentors. So we had, that's your cue. I don't know. We've got, I think we've got something. Hold on. One moment, please. Hold, please. Oh, this is the big one? Yes. Look what we have. This is for you. This is for you, Alexis. First, look at that. Don't worry. We didn't forget the rest of the mentors. We've also got a memento that says ExxonMobil that reminds us of our time together. Judges, you've got gift bags here. I think that's everything that we've got for today. Is there anything?
We got trophies for the judges too.
Oh, the judges get trophies too. Little mementos for coming and participating. To all of the employees of ExxonMobil, you are what make this happen. Thank you for your contribution. But to all of you who have participated, as you've heard me say, there's so much power in the conversation, and you have every one of you, demonstrated new skills. You've accessed the power of Aggies Invent. You've seen transformation in your presentation skills. I've seen it. Have you seen it? Did you hear that beep, by the way? Because if you didn't, I'm going to be talking to my therapist about hearing noises in my head. I'm just kidding. You have done an amazing job. Do one more thing for me. Walk out and meet me on the steps, and we're going to pose for a picture with David Cook. That concludes our prepared remarks. That's Aggies Invent. ExxonMobil, thank you, everyone. Thank you.
Oh yes, I was gonna say I didn't know where all the other
One was back there, one left early.
So we have season tickets.
Oh, no.